Okay, so now let's get into example 1, where we're asking to evaluate the sine, cosine, tangent for 90 and negative 90 degrees, which I forgot to write in those symbols there. So we want to make sure we have them. Now, the important thing is creating a right triangle is not going to work here because, previously what we looked at with the unit circle was these special right triangles, like a 45, 45, 90 degree triangle or a 30, 60, 90 triangle. But the issue is, when we're talking about the 90 degree angle, we don't have the adjacent or the opposite sides anymore, right? If we just had an angle here, like let's just do a 45, 45, 90 triangle, we have the hypotenuse, opposite, adjacent, right? And we can go ahead and figure those comparisons. But when we're looking at the 90 degree angle, we have the hypotenuse, but we don't really have an opposite and adjacent. So what we're going to want to do in this case is actually go back to our definition that the sine of an angle, based on that, if we remember the unit circle when the radius was equal to 1, that the sine of theta is equal to the y-coordinate of the point on the unit circle, where cosine of an angle is equal to the x-coordinate, and the tangent of the angle is equal to y over x. So the right triangle is not going to help us here. What we have to do is go back to what we talked about with that unit circle. And so again, we can look at here and see the circle with all these intercepts, right? Because remember, this all has a radius of 1. But we can't create a triangle at these points here. So therefore, we're just going to use the representation of the x and the y coordinate. So for 90 degrees, which is going to be 90 degrees is right here, all right, we can see that we're dealing with the coordinate point of xy. So in theta is equal to 90 degrees, we have the coordinate point 0, 1. So from there, what I can do is now evaluate the sine, cosine, and tangent. So the sine of, let's actually just do 90 degrees because that's what I had. So, all right, it said theta is 90. So sine of theta, in this case, is going to be 1. The cosine of theta is equal to 0. And the tangent of theta is going to be y over 0. Well, we can't divide by 0, so that is going to be undefined. Now, if we say theta is equal to negative 90 degrees, okay, now that's something different. Negative 90 degrees, obviously, is going down here. So we're going to use this coordinate point to evaluate the sine, cosine, tangent. And therefore, the change here is sine of theta now is negative 1, because that's the y-coordinate, 0, negative 1. The cosine of theta is still 0, right? You can see it actually, the x-coordinate didn't change off the y-axis. And the tangent of this theta is just because of the negative 1, it's not going to change. It's still going to be undefined. Okay, so that's how we're going to evaluate for the sine, cosine, and tangent when they basically lie on the x and the y axis. We can't create a triangle, so we're just going to go ahead and find the coordinate points. And just kind of notice like the reflections that are happening here. I chose the 2 points on the y axis. I could have chosen the points on the x, but I wanted just to kind of see how these reflections kind of work. And then just remember these are all represented by the x and the y coordinates. So if you're on there. All right, now let's go and take a look at some other angles that we're going to be looking at that are also in 2 different quadrants.